let's do practice problem 7 on page 229. Let me read it out loud to you. An airplane passenger carries a 250 Newton suitcase up the stairs, a displacement of 4.2 meters vertically and 4.6 meters horizontally. A, how much work does the passenger do on the suitcase? And the same passenger carries the same suitcase back down the same stairs. How much work does the passenger do now? So let's, now here's what I'm going to do. I'm going to do this the hard way. Lots of calculations and a real pain in the you-know-what. And then we'll do it the easy way. And you'll see that if you really understand physics, then you can do things the easy way and get things done quickly. All right. So here's what we're given. Now we have a staircase like this. I'm not going to draw all the jagged little stairs because that's too hard. And we had a horizontal displacement and a vertical displacement. And the horizontal displacement, it said it was 4.6 meters. And this was what, 4.2 meters, I think? Is that right? So we'll call this delta x, and we'll call this delta y. Now we had a suitcase, and we're lifting the suitcase up. I'm not going to draw the person. I'm just going to draw the suitcase. And it said that the suitcase had a weight of 215 newtons. Okay. And we're going, now for part A, let's do these separate. Here's part A. What are we trying to find in part A? The work done to carry up the staircase. Okay, and then we'll do part B separately. So let's solve. Well, let's do this the hard way. And that is you just use a sledgehammer. You just use the basic equation and you do exactly what it tells you to do. Well, the work done is, let's write the equation down. The work is equal to the force times the dot product with the displacement. Right? Well, what does that mean? The work is the force that's being applied, the force that the person is applying, times the displacement, the total displacement, times the cosine of the angle between the force and the displacement. And so you go, okay, well, what's the applied force? Let's figure that out. Well, I look back here and I say, well, gravity is pulling down with 215 newtons. So the person has to pull up with an applied force that's equal to the weight. Now, the suitcase is moving up the staircase with constant velocity. There's no acceleration here. So there's no net force acting on the suitcase. So therefore, the applied force is just equal to the weight, except that it's up instead of down. So we now know that the applied force is equal to 215 newtons. Now, what's delta R? Well, the suitcase goes from here up to here. So delta R is going to be, well, you can see there's a right triangle here, the x component squared plus the y component squared, take the square root. I'll just go ahead and plug the numbers in. The x component squared plus the y component squared. Now, it turns out this is really not necessary to do this if you understand what you're doing, but that's okay. Delta R, I think when you do the math, you get 6.23 meters if you plug that into a calculator. Everybody follow that? Now, the tricky thing is to figure out what is the angle in between the force and the displacement. Well, look at the picture. Here's the force, and here's the displacement. I want this angle right here. Well, that angle, if you think about it, look at the triangle here. This angle, alternate interior angles are equal or something like that. You know, we have two parallel lines and a line crossing it. So this angle is equal to this angle. And I could use delta R and use inverse cosine or inverse sine if I go over here, but I'm going to use inverse tangent. And now you have to be really careful, because inverse tangent, you do the opposite over the adjacent. So it's really the x over the y, which is the opposite of what we usually do, but we don't want this angle, we want this angle. So this is going to be the opposite, 4.6 meters, over the adjacent, which is the 4.2 meters. And when you go through that, you get 47.6 degrees. Okay. Well, now we've got everything we need. The applied force is 215 newtons times delta R of 6.23 meters. And then you multiply that by the cosine of 47.6 degrees. Now, by the way, you could have done this a different way. Remember, cosine is the adjacent over the hypotenuse. So you could have just, instead of figuring out the angle and going cosine of that angle, you could have just used that ratio of the adjacent, which is 4.2, over the 6.23. But you get the same thing either way. Now, when I plugged this into my calculator, I got something very close to the right answer, or the answer that's in the book. I got 905 joules. Now, the answer is 903 joules, isn't it? The reason it's 905, I think it's just rounding off stuff. So that's okay. I would accept this as a correct answer. And look, we've done everything right. But if you understand physics, the physics of this, you can take a dramatic shortcut. And the shortcut is this. Only the parts of the force and the displacement that are parallel to each other do any work. In other words, I can ignore delta x totally and just look at delta y. Here's delta y, it goes up like this. Here's my force that's up like this. They're both up. So I can just say, well, the work that this does is the work it takes to lift it 4.2 meters. So I can do this much more easily by just saying the work is equal to the applied force. But it's up, so how much displacement is up? 4.20 meters. And they're parallel, but they're also in the same direction because the angle between them is 0 degrees. Well, cosine of 0 degrees is 1. And you get a work of 903 joules. So that's the, now look how easy that is. So if you understand the physics involved, you can say, oh, work is only done when the force components and the displacement components are in the same direction. I can just do that. Here's the force and displacement that are in the same direction. And I don't have to go through all of this stuff. Okay, now let's do part B. Well, there the find is the work to carry down the staircase. So in this one, the suitcase is up here, and we're going down this way. Well, we could go through all of this again. And I want to show you that it actually works. You go work equals F dot delta R. I'm just going to go here. We're going to say the FA, which is 215 newtons, times delta R, and delta R is the same thing. It's just the 6.23 meters. But now what's the angle between the force and the displacement? Look at this. Here's the force, but now the displacement is like this. So I'm going to draw this on this displacement like this. And basically all you have to do is take the 47 degrees. Here's the 47.6 degrees. Subtract it from 180 to get this angle. And that's the angle between the force and the displacement. Here's the force vector, the displacement vector. If I put them tail to tail, I get this angle right here. So theta is going to be equal to 180 degrees minus 47.6 degrees. So 180 minus 47.6. And I get 132.4. And so I'll multiply by the cosine of the angle between 132.4 degrees. Now, of course, in your trig class, you should know that supplementary angles, the cosine, are the same, but opposite in sign. Y'all finished? Just put it right here. Well, let's just show it. Here's my calculator. So I go 215 times 6.23 times the cosine of 132.4 degrees, and I get negative, oh, that's interesting, negative 903 joules. Now I wonder if over here, I bet if I did this, let's just try it here. 215 times 6.23 times the cosine of 47.6. Ah, I get 903. Oh, that's good. Okay. So I get the right answer, huh? Of course, that's the long way to do it. Let's do the shortcut way and just say, look, it's the force and displacement that are parallel to each other that matter. So I'll take the force, 215 newtons. Now that's up. Now the displacement that's parallel to that is 4.2 meters. Down. And then what's the cosine of the angle between up and down? Well, this is -1. That's where the negative comes from. Negative 903 joules. So really, to do this problem, all you needed to do for part A is this, and all you had to do for part B is this. This is way easier than going through all this, but it is the same stuff. Okay? Any questions? That is all.